Alright, so let's try the next problem. Here we're finding the limit using algebra. In this case, we have some absolute functions, and we have to be a little bit careful when we're dealing with absolute functions. So we'll break it down into parts, and that way into a piecewise function, and this will help us actually look at this a different perspective. So again, if you plug in 4, right, if you plug in 4 in here, you could, right, to find the limit, but we will see that this will give us 28 minus 28, and 4 minus 4 will give us 0 over 0. So again, this wouldn't allow us to do the limit directly, right? So what we're gonna be doing instead is, it means that we have to do some manipulation of algebra, some maybe factoring to help us with this. So what we're seeing here is that we have an absolute value, and also we notice that those two have a common factor. The common factor is 7. So what about if we begin by writing this as 7 times 4 minus 7x all over 4 minus x. This will give us, because 7 is a common factor and 7 is positive, right? Actually, we're going to factor positive 7. We could rewrite this as 7 absolute value. Maybe I'll do another extra step. 7 4 minus x within the absolute value. Now, if you're trying to cancel those two, I'm going to say, hold on, it's not that simple. So because this is a product, right, we could separate the 7 from separate it to a different absolute value. So we can rewrite it as the limit 7 absolute value of 4 minus x. And again, because 7 is positive, the absolute value of 7 will be positive 7. So we can, I don't know why I wrote a 7 there, because maybe I was talking about 7. And I have to be careful here. I need to make sure that I state that this is coming from the left side. So the limit of the function 7 times 4 minus x all over 4 minus x. We actually haven't done much, right? We just simplified up what we have here. So what we need to figure out is, what is the absolute value of 4 minus x over 4 minus x, right? We cannot just cancel that because it's not that simple. What we're going to do is we're going to investigate what does it mean to be 4 minus the absolute value of 4 minus x, right? So what we have to consider here is two cases. What happens if x is greater than 4, and what happens if x is less than 4? That's all we have to worry about. So when x is less than or equal to 4, and when x is greater than 4. All right, so why? Because remember, this value, the value of the function, needs to stay positive, right? Positive. So let's say if x, right, is less than or equal to 4, just think about a number that's less than 4, right? Like 3.999. So if you have 4 minus 3.999, right, what do you have here? The difference is still going to be positive or 0. So there's nothing to worry about. The number will always be positive no matter what. So that means that for this scenario, we can actually drop the parentheses, right? Let me give you a different argument now. What happens if x is greater than 4? If x is greater than 4, then what you're going to have here is 4 minus a bigger number, right? So for example, think about a number greater than 4, like 5. Now you have 4 minus 5. This will give you a negative 1. So as soon as this number is greater than 4, this number, right, whatever is inside the absolute value, now is negative. So what we're saying here is that this number that we have here is negative, right? But that cannot happen. Why? Because we have an absolute value function. This is supposed to be positive, right? So that means that what we need to do is turn this number to be positive. So how do we do that? So that is consistent with that function. What we're going to do is as simple as surround this with parentheses and multiply by -1, right? We have imaginary -1 in there. By doing that, then you have fixed the problem. So having said that, now when we go back to the limit here, now you have something to replace this with. So since 4 is coming from since x is coming from the left side of 4, that means that x is less than or equal to 4. So that means we can replace the absolute value with 4 minus x. Now remember that there's imaginary multiplication of 1 on the bottom, so that means that we can come back here, and if you notice now, since there's no absolute values, it just makes it proper for us to cancel those two common factors. Seven over 1, right? Which we're not going to write the 1, but it's there. So what is the limit of 7? So what we're going to do is we're going to try to replace x with 4, right, in here. But there is no x for us to replace with. There's no x for us to replace. So when you have with the limit of a constant, will always be itself. And that's it, right? So 7 is the absolute value. With the same logic, we're going to use almost the same steps to jump in to here, right? So we're going to use the same lines that we use above to argue that the limit of this function will be 7 times the absolute value of the difference of 4 minus x all over 4 minus x as x approaches 4 from the right side. All right, so the only difference that's going to happen is when we decide to use what type of how are we going to replace the absolute value. So if we look over here now, as x approaches 4 from the right side, that means x is greater than 4. So with the absolute value is going to look like this. It's going to be the same as this. So we're going to take the limit of 7, and instead of writing the absolute value of 4 minus x, we're going to have negative 4 minus x all over 4 minus x as x approaches 4 from the right side. Now this, we have to be careful, but we can actually multiply those two together. We're going to have the limit of negative 7 4 minus x all over 4 minus x, and we're gonna put a product of 1 there just to remind us that we have a factor there. And so these two will cancel each other out, right? We can see those now. We can cancel them out because we no longer have the absolute value. And now we have the limit as x approaches 4 from the right side of negative 7 over 1. But again, we're not going to write the 1. We could if we want to, not a big problem. And the absolute value of a constant, as we justified before, is going to be negative 7. All right, so we found the two limits, right, for both both of them right here. It's right there and right here. They happen to be almost the same, but we can determine that they're different because one of them is positive and one of them is negative. So because both of them are not the same, right? They're not the same. That means that the limit of the function as x approaches 4 does not exist. Period, right? And that's it. So it's a very interesting problem because we have to deal with the absolute values. But I hope you guys found this helpful, right? All right. Let me know if you have any questions.